everybody, I'm going to continue on homework 1.2. I'm going to continue with challenges 9 through 13. So challenge 9, 10, and 11 is about the NBA finals for this year. So this is actually real data, by the way. Ticketmaster charged the amounts shown for the first 3 games of the 2015 NBA Finals. The total cost for an order to attend Game 2 was $4,729.69. So we have this chart here. We have Game 1, the ticket price was this much. Game 2, the ticket price was this much. And Game 3, this was the ticket price. There's also a $7.75 convenience fee, a $2 facility fee, and a $2.50 shipping fee for each order. So the very first thing, as I've said on all my videos, is I want to do the 3-columned chart, which is know, need to know, and then my strategy. So first, we can go through the problem and actually underline or highlight the information that we will put in our no column. So I see that the total cost for an order to attend Game 2 was that much. And since this top part is in terms of Game 2, I'm going to assume that if we're going to Game 2, then that's how much the ticket will be. And then there is a $7.75 convenience fee, $2 facility fee, and a $2.50 shipping fee for each order. Okay, so I'm going to write all that down in my column. And then we have fees. We have a $7.75 convenience fee. I'm going to abbreviate. The $2 facility fee. And then the $2.50 shipping fee. All right, so at this point I would ask, is there anything else that we know about this problem? Some students brought up the fact, well, Game 1 tickets cost this much and Game 3 tickets cost that much. And my question is, are we going to use that information to represent us going to Game 2? And we would not actually need that information, but it's important that if given a diagram of some sort or a chart, that the students can actually pick out what they need. So then our need to know, we're on challenge 9, it says to write an equation to represent this situation. Well, if my total cost for the order was the $47.29.69, and I know how much each ticket costs, and I know the fees Well, what is the only thing that we don't know in order to get this total here? And we need to know how many tickets were sold or were ordered. And the other very important thing about writing an equation is to define your variable. So I can use x, and x can be number of tickets ordered. So today in class I brought up, or I asked this question, why is this column important? And some of the answers were, well, instead of going back and reading through the whole problem, you actually have all of your important, like your key facts here. Another student said, well, this tells you what will be in your equation. And I'll have to think about another one. Sorry, I had it on my mind, but now I can't remember. Okay, so we know that the total cost for the order, and I brought this up, we're ordering tickets from Ticketmaster, which is usually online. But I mean, even if you're ordering over the phone, your total cost for the order is $4,729.69. So total cost is, the is the equals. Alright, so we need to figure out what's going to go right here on the left side of the equation. I think the first thing that students saw today was that if each ticket for game 2 costs this, then you would multiply the number of tickets by it to see how much all the tickets together cost. Because these fees here, it states that you have these fees per order, not per ticket. So we know that those fees will be added to the total for all tickets. So let's see, I'm going to go ahead and add those up. 775 plus 2 plus 250. It's 1225. Alright, so I'm going to label this. So this is price of ticket. This is number of tickets. This is all fees. And when you add all that together, you're going to get your total cost for the order. So I'll come down here and solve. You want to subtract those fees from the total cost. In order, oh wait, I think I did something wrong. 472969 minus 12. Alright, so you want to subtract the fees from the cost of the order. Because the fees were added on at the end after the ticket prices were added up. And so if you subtract this from the total cost of the order, you will get the total cost for the tickets. So I get 471744. And then this goes away, so I bring down that, and I'm going to divide by the cost of one ticket, so we can see how many tickets were bought. Three. I think I might have made a mathematical error somewhere because Alright, so challenge 12 and 13, it says the letters A, B, and C represent non-zero constants, so solve the equations for x. Now the reason why that information says that they are non-zero constants is because if we're solving for x on number 12, we have ax minus b equals 12.5. We will end up having to divide by a at some point, and you cannot divide by 0. So therefore that's why it states that a, b, and c are non-zero constants. So I'm going to add b. Now, a lot of students ask, why can't we add 12.5 and b together and get 12.5b? And so my response is, or it's actually a question, do we have any idea what b is? And they'll say no. And so my next question is it possible to add 12.5 to some number that we have no idea what it represents? We have no idea what that number is. And they're like, no, you can't do that. So that's why you can't add the 12.5 and the b. Another funny thing is that you can't put an apple and a banana together and get a banapple. So another way to describe it is that they're not like terms. Okay. So I divide by a, and x equals 12.5 plus b, all divided by a. Alright, so let's do number 13. And same information applies. A, b, and c are non-zero constants. So cx minus 4b equals 5b. So I'm going to add 4b, and what do you know? These are like terms because they have the exact same variable, and the variable has the same exponent. So the exponent is the understood exponent of 1. It's normally not shown because it's understood to be there. So since these are like terms, I can add those together to get 9b, because 5 plus 4 is 9. And then I'll divide by c to get x equals 9b all over c. Okay? So that is it for homework 1.2.